This video is presented to you by www.testprepadda.com. Testprepadda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Dear students, in the previous chapter, that was chemical equilibrium, we had already talked about equilibrium. Now here, as the name of the chapter suggests, ionic equilibrium, we will talk about those equilibria which involve ions. Now question arises, what type of substances produce ions? You must have heard about electrolyte. Now what are electrolytes? Those substances which produce ions when dissolved in water or when melted. Such molecules can conduct electric current and hence such substances are commonly known as electrolytes. But there are substances like urea, sugar, they do not produce ions on dissolving in water or on melting. That is why these substances are called non-electrolytes. So before I actually start this ionic equilibrium, I will tell you about acids, bases, and salts. All these are actually electrolytes. Now there are different concepts of acids and bases. First of all, I will talk about the Arrhenius concept of acid and base. According to Arrhenius, an acid is a substance that dissociates and gives hydrogen ions H plus when dissolved in water. For example, if I write HCl, when HCl is dissolved in water, HCl gives its H plus to H2O, and this way we get H3O plus and the remaining part is Cl minus. H2O is the solvent, so we write liquid, and HCl is dissolved in H2O. For our convenience, we can write H plus in place of H3O plus. Now, according to this Arrhenius concept, a base is a substance that dissociates into hydroxyl ions OH minus when dissolved in water. For example, NaOH plus H2O. This NaOH breaks into Na plus OH minus. Aqueous means Na plus is surrounded by water molecules, OH minus surrounded by water molecules. Now please keep in mind, on the basis of above concept, we can say acid or base. These are relative terms. HCl is an acid here with respect to H2O. NaOH is base here with respect to H2O. So acid and base, these are relative terms. Now the problem is this definition or this concept is limited to H2O only. That is why a more generalized definition of acid and base came into picture, and that is Lowry and Bronsted concept of acid and base. According to this theory, an acid is a substance that can donate a proton, that is H plus, to any other substance, and a base is a substance that can accept a proton from any other substance. For example, if I take NH3 and HCl, now HCl donates its H plus, that is proton, to NH3, and NH3 accepts that H plus, and that is why we get NH4 plus here and Cl minus. Now you can see NH3 is accepting H plus. That is why according to the definition NH3 is a base here. HCl is giving its proton. That is why according to the definition HCl is an acid here. Okay. Again, if you see the example, you can say NH3 is a base with respect to this HCl acid, and HCl is acid with respect to this NH3 base. Again, acid and base are relative terms. Now, if you look at this example carefully, you can see after accepting H plus, NH3 becomes NH4 plus. Now the H plus is with NH4 plus. That is why NH4 plus is capable of donating that H plus. And if Cl minus accepts that H plus, we will get NH3 NHCl. That is why NH4 plus here is acid and Cl minus is base. Now you can see NH4 plus we have got from NH3, which is a base. We say this as parent base, and NH3 and NH4 plus are called conjugate acid base pair. Similarly, you can see Cl minus is produced from this HCl. That is why HCl is parent acid of Cl minus base, and HCl and Cl minus will be called as conjugate acid base pair. Okay, so now how do we define conjugate acid or conjugate base? A base formed by the loss of a proton by an acid is called conjugate base of the acid, whereas an acid formed by gain of a proton by the base is called conjugate acid of the base. For example, if I take HNO3 as the acid, then How do I write the conjugate base? Use the concept. If you want to write conjugate base of a given acid, then remove H plus. How many H plus? 1 H plus. If I remove 1 H from here, it becomes NO3. Now if I remove 1 plus, it will become NO3 minus. So NO3 minus is the conjugate base of this HNO3 acid. Now I'll take a more difficult example. If I write uh, H2SO4, H2SO4, don't get confused here. If I ask you the conjugate base of this acid, do not remove both H plus. Otherwise, you'll get SO4 2 minus. As per the concept, if you want to write conjugate base, then you have to remove only one H plus, and this way the conjugate base of this H2SO4 acid will be HSO4 minus. Getting the idea? Now, if I write HS minus, HS minus, HS minus is having H plus. That is why if I consider this as acid, then I can write conjugate base as S2 minus. S2 minus. I have removed one H plus. Now if I consider this HS minus as base, then I can write conjugate acid of this base. What will you do to write conjugate acid of this base? You give one H plus to this HS minus, and when you give one H plus, it will become H2S. Got the idea? So, what is the conclusion here? HS minus, for HS minus we can write conjugate base as well as conjugate acid. So HS minus behaves both as an acid as well as base. So those substances which behave both as an acid as well as base, those substances are called amphoteric, amphoteric or amphiprotic substances. Got the point? Okay. Now I will talk about the Lewis concept of acid and base. Although Lowry and Bronsted theory gave a more generalized definition about acid and base than the Arrhenius theory. But in many cases, the theory failed to explain the nature. For example, if I give you BH3, BH3, if you compare at the atomic level BH3 and NS3, boron is the central atom, nitrogen is the central atom. One central atom, three corner atoms. So if you look at this at atomic level, BH3 and NS3, both should behave in a similar manner. But actually, NS3 is a base while BH3 is an acid. Now, if I use the concept of Lowry and Bronsted, BH3 should give H plus proton when treated with a base or when treated with water or when dissolved in water. But but BH3 is not a protonic acid. It does not give H plus, but it shows the characteristics of acid. That is why we say Lowry Bronsted theory failed to explain the acidic nature of BH3. And to explain this, Lewis acid and base concept came into picture. According to this concept, an acid is substance which can accept a pair of electrons, and a base is a substance which can donate a pair of electrons. If you look at this NH3, this nitrogen is having lone pair, and and octet is complete. Octet is complete. That is why this NH3 is capable of donating this electron pair. And so according to Lewis theory, this NH3 is a base. Now if I talk about this BH3, the central atom is boron. If I write the electronic configuration of this boron, 1s2, 2s2, 2p1. Total 5 electrons are there. And in the excited state, we can write 1s2, 2s1, 2p2. If I draw the orbitals, then you can see one orbital is empty. So BH3 is capable of accepting an electron pair. So BH3 is an acid as per Lewis concept of acid and base. In the P block, you will learn about the compound H3BO3. H3BO3. This is boric acid. And in that chapter, you will learn that H3BO3 is not a protonic acid. It does not give H plus when dissolved in water. But this H3BO3 accepts OH minus when dissolved in water. That is why H3PO3 is monobasic Lewis acid. So if I dissolve H3BO3 in water, it takes OH minus of water and becomes BOH whole 4 minus plus H plus, and this way this H3BO3 boric acid shows the acidic character. So keep in mind H3BO3 is not the Lowry Bronsted acid, it is Lewis acid. Now attempt these questions. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.